working with design, schematic fabrication, 3D visualization, and along with that, how to create Gerber file and how to order it. If you are not having a particular machine, PCB design machine, in that case, we can order a particular PCB from some specific platforms. We will see in this particular session. Whatever PCB we are creating, we are designing, we can set it as per desired dimensions, and we will see how to create multi-layered PCB also. However, there is no upper limit in layered approach of PCB, but the platform I will show you, in that we will be able to create up to 32 layers PCB. Many times participants ask whether we can create two side PCB or four side PCB or not. But with these platforms, even 32 side 32 layered PCB can be created. For example, you are working on some very high performance research applications like defense, smart cities, and in that case, single plate is not sufficient. One side plate is not sufficient. We have to work with multiple plates, okay, multiple layers. We will see that part also. But during this session, we will see how to create PCB from scratch. Before covering any demonstration, first of all, we will see which features are available in these applications which we are covering. Schematic capture, schematic design, PCB layout we will be able to create. 3D viewer is available if we want to view our PCB in three-dimensional space. In multiple dimensions, we will be able to see it. By which way it will be looking from top, bird view approach, left profile, right profile, from multiple angles we will be able to see. And what is benefit of using these simulators, that we can work on our experiments, we can work on our research based experiments very easily without touching any physical device. Otherwise, first of all, for example, we have purchased some sensors and we are directly going for some wirings, we are directly using some haphazard wiring, and in that case, in physical aspects, there may be loss of your infrastructure, there may be burning, there may be some issues related to conductivity, related to so many things. But if we are working on simulators, then zero loss. Okay, simply drag and drop, we will be able to see if we are using this particular device, then what will be the output or what will be the behavior. DRC ERC check, that is also possible. We can analyze a particular PCB, a specific infrastructure, in terms of its rules, design rules. Okay, whether it is valid or not, whatever communication we are doing, whatever interface we have used, whether it is valid or not. Okay, and finally, Gerber export. We can export to a particular file, which will be used in printing machine if we want to print it. Okay, so design rule checking, electrical rule checking, whether some particular voltage, if we are applying some specific voltage, whether it is valid or not. Okay, otherwise, if we are doing it physically, in that case, it can burn your infrastructure, it can burn your device, okay, or entire PCB. Logical connections, physical layouts, each and everything is possible. Detection of unconnected pins, many times we import some specific gadgets, some specific sensors, whether these pins are associated or not, whether these connections are valid or not. Okay, incorrect pin connections, floating components, these we can analyze. So we will see which platforms are available. Okay, nowadays so many tools available for PCB simulation, PCB design. EasyEDA is one of that. I will show you demonstration of creating PCB on this platform. It is online. Okay, this one is online tool. No need to download anything, no need to install anything, because simply on browser, web browser. Sir, yes, it is cloud, it is cloud compatible, cloud based. Okay, so this is one platform, that is easy EDA, and everything you will be able to do. For example, this type of design we want to create. Okay, we want to view from three-dimensional format in this way. So you can see schematic capturing, PCB design, 3D visualization. Okay, so you can see that first of all we will create a circuit. After creating this circuit, we can convert it to 2D or 3D format. Okay, so this one 3D visualization is available, and unique features you can see cloud based, and desktop variant is also associated. This is one platform, so it's up to you whether you want to download and you want to work on your laptop, or you want to work on cloud. Okay, what is benefit of working with cloud? No need to download anything, no need to troubleshoot anything. Simply open web browser. Even on your mobile phone also, on web browser you will be able to work with it. So this is first platform. And second very powerful platform that you can use, that is KiCad. Okay, this is KiCad. Okay, free and open source, cross platform, open source PCB design suite. Whatever features we are covering in easy EDA, these features we can use in KiCad. Now the question arises, what is difference in easy EDA and KiCad? If I am using easy EDA on browser or on desktop variant, in that case how it is different from KiCad? If we want to work with so many dimensions, a complex PCB like 100 layered PCB, okay, or more than that, in that case we can use KiCad. If we are using free variant of easy EDA on cloud, in that case 32 layers PCB can be created, but that is also sufficient. 32 layers are more than sufficient until and unless we are working on smart city or IoT or some particular project like military or defense applications. Okay, so in same way you will be able to work with it. This one here also you can. Is this screen visible to all of you? Whether screen and audio is here? Okay, okay, so you can see that, and different, its rich community is available, online tools available, it is freely available. Okay, and party libraries can also be integrated with KiCad. Okay, free and open source. So it's up to you whether you want to work with KiCad or easy EDA. Now we will see some demonstrations with easy EDA. Okay, so each and everything whatever I am covering in this session, these are given in this presentation. I will share this presentation to all of you at end of the session so that you will be able to follow these steps. Okay, along with that OSH Park is also available. Okay, OSH Park, Upverter. So these applications, these platforms you will be able to use. So, okay, so drag and drop your KiCad files, and we will be able to create very effective PCBs. Upworter, this one. Okay, so as an academician, as a teacher, as a research guide, we can ask our students, our researchers to use these platforms. All of these are completely free. Okay, so these links I have given in this presentation. At end of this session, I will share to all of you. Okay, Osmond PCB is also available, and JLC PCB. This platform we use to make our PCB in printable format or production ready or deployment ready. Deployment ready means, for example, we have created one PCB and we want to get it physically. Okay, so similar to Amazon, Flipkart, we can order our PCB from this website. Okay, JLC PCB, you can see this one. So we will see this part also. Whatever PCB we have created, how to order it from this platform. Okay, EasyEDA is already integrated with JLC PCB. Whatever circuit we are creating in EasyEDA, we can send it to this platform and we can get it. Okay, and in very less cost. It will tell price of each and every component and along with that how much it will cost in multiple layers, in single layer or multiple layers, each and everything will be given. Okay, so this one. Now we will see how to work with this platform. So you can see that multiple layers are given, so up to 32 layers we can order our PCB from JLC PCB. Okay, so you can see that one layer, two layer, or up to 32 layers. Now we will see how to work with EasyEDA. EasyEDA.com, this is official website. You can download, or if you want to work on cloud variant, you can work on it. So I will prefer online variant so that no need to download anything and directly on cloud we will be able to work. Design online. Simply I have opened this website easyeda.com and I am clicking on design online. Now there are two options in EasyEDA. One is Pro Edition and second is Standard Edition. Both of these editions are free. No need to issue. Okay, no need to worry about that. But as a beginner, if you are new in this particular domain, better to start with Standard Edition. In Standard Edition, most of the libraries are available. Most of the components you will get. Okay, in Pro Edition you will get some new interfaces, some new sensors. Okay, for covering this session we will start with Standard Edition. Simply I will click on this option Standard Edition and it is loaded. Here you can see that complete palette of different components are attached here with common library. Okay, to work with this platform, first of all we should log on. Okay, so I will log in here with my Google account. Simply with our single sign-on account we will be able to use it. So you can see that it is mentioned here, one account all services, JLC PCB, JLC 3DP, JLC CNC. Okay, EasyEDA. So I am clicking on sign in with Google So everybody nowadays having Google account, and I'm logging in with my account so that I can create a circuit. I can create a PCB in EasyEDA. So after logging in to EasyEDA with my Google account, you can see that this is the dashboard. This is working panel of EasyEDA, and here at top left, this palette is available here. Project. This one I am highlighting. This is project. Okay, we can create a new project. Common library. Which parts we want to attach. Okay, so common library, you can see that this one is ground, resistors, different capacitors, power supply, connector. Okay, if a particular part is not available here, for example some part is not listed here, in that case what to do? We can search that part on this library. Okay, so this one, for example I need a particular register of particular dimension of specific units. Okay, this ohm or this particular voltage, a specific component is required, so we can write. Okay, so you can see that ceramic resistor 10 volt. Okay, 10 volt 2.2 ohm resistor, this one 1.9 mm, and this one. In same way, if I want to work with connectors, okay, so 1.2 t connectors. So whatever component is not available by default, we can import from its library. Okay, so you can see ceramic resonators, anything. If you want to work with antenna, so you can see which type of antenna you want to take. So this one C0402, if I want to see its configuration, I want to see its frequency, on which particular frequency for which specific dimension this antenna will work, we can see it. And how much its price, we can see its price also. Okay, so you can see this one. So screw terminal, different IoT gadgets, these can also be attached. Amplifiers. Now we will create one project, and then we will see how to create its final PCB. New project. Okay, so new standard project, any name you can specify. Okay, or you can use this option also. At top you can see this one, new schematic, new project, new schematic. Now you can see that this is our working panel, and here we will be able to create a schematic. Up to this point, is it clear? Very simple. As simple as any other GUI based software. Click on file, new, either on project or directly click on schematic. If you are when we click on schematic, automatically a new project will be associated. Okay, why we are starting with schematic, not with directly PCB? Because first of all we are creating a circuit. We will create a circuit, and after that we will associate some components. Okay, some components of different configurations, different connections. Now just for demonstration I am taking LED. So I have I have put in search LED. Okay, simply, so I am zooming it so that you will be able to see it clearly. This one LED. Now this one, in LED you can see this is major main category. In this category different types of LEDs available. So red, green, blue. Okay, and different colors we want to use. Okay, so this one 3 mm red, 3 mm green. So I want to take this one. Simply click here. One red LED we have imported. Now I want to take one green. This is one green. Okay, so simply drag and drop. As simple as paintbrush. Now red, green, and blue, and one blue LED we have taken here, and you can see that as I am placing my mouse, this is a touchpad. Okay, touchpad pointer, automatically it is showing me that particular line. For example, one more I am taking, so alignment I can see very easily. Okay, whether these LEDs or whether these components are aligned or not. Okay, now you can see that this one. Okay, I want to zoom it. Okay, zooming. Now if I want to rotate it, okay, for rotation you can see press R. Simply selected, clicked on that particular component, and I am pressing from my keyboard R. Okay, this one. Very simple. Now you can see this one. Now three LEDs we have taken. One ground we will take GND, ground connection. So for alignment we will place it here. So if I want to rotate it, we can do, otherwise keep it as it is. Up to this point clear? Very simple. Now saving, so for example my PCB, any name we can specify. Now I want to give it supply. Okay, so common library, in common library, so you can see that this is DC. DC1 we have taken. Very simple. Now we want to go for connections. We want to put some connections. Okay, one DC 005. Okay, so many other available. So if I want to connect it with USB, you can see USB type A male, type A female, USB micro, and so many other things. If you want to go for LED, this type of LED screw. So whatever is in your mind, whatever circuit you want to create, you can select. If something is not available, no need to worry, select from this platform. Okay, okay, library, and it will give you all options available. Okay, generally what we do, for example, something is not available on Amazon, we go to Flipkart, we go to other platforms. Same thing here, if something is not available by default, we go for alternate platform and we select it. Okay, now we will create connection. Simply this is connection wire. So you can see this is wire. So and you can see that how much it is easy, and there is no loss. Even if I create wrong connections, I make wrong connectivity, there is no issue of any burning, there is no issue of any damage. Okay, otherwise if physically with wires we are doing all these things and we are giving some power supply, you can imagine what can happen. Okay, your device, your PCB, your plate can burn. Okay, even person can also be burnt who is working on that project. Okay, so you can see that this one we are creating this connection, simply selecting. Okay, rather so to simply select and drag. Okay, so you can see as we drag in MS Word. Okay, in MS Word what we do, for example I want to create a diagram, drag and drop, insert shape. Okay, and then connectors. So click. Now I want to connect. If some resistor is not available, in that case you can take it. So for example, this one. Okay, I want to take this one. Okay, or this place where I want to place, but its cost and you and whatever device, whatever component I am taking, I can see its price also. So you can see at bottom left, dollar 2.3. Okay, so in $2.3 it will be available. If I want to see this, it is available free. If I want to place it, this one, many components are integrated in free also. Okay, so you can see this is, so if I want to place a particular component and it can work lt1g, so its cost is $0.05, so it is quite cost effective. But if I will take this one, so in same way, if I want to work with some other, like this one, so its cost might be high. So you can see $0.08, 0 point this one. Okay, so $0.67. Okay, so after doing after placing our components and connections, now our circuit is ready. Up to this point, is it clear to all of you? Yes.
Yes. So if we are choosing a component which is a paid component like so it will not allow to simulate also without paying any
No, no, it will simulate, but at the time of order, we will have to pay for it. Okay, for example, in simulation, there is no issue. For example, it is showing $200. So it doesn't mean that we will have to pay 20,000 rupees. Okay, so $200 component we can simulate, but if I need PCB with that component, then I will have to pay. They will give me price. Okay, BOM, that is known as, that is concerned with BOM, bills of material. Okay, so in this this option is available, that whatever components you have imported, this is the bill of material and its total cost is this one. And if you want to order, you can order it. Otherwise, uh, for research work, it is completely free. Is it clear to all of you? Remote participants also kindly confirm. Up to this point, is it clear? Okay, now we will see how to move ahead. So up to this point, we have created one schematic. This circuit is ready. Now I need its PCB. I need its, first of all, I want to see by which way it will look. What will be its look and feel factor? Okay, so you can see that, first of all, we will see cross probe. Cross probe means it will check whether it is correct or not. In tools, cross probe. Okay, if there is some problem, then it will show you the message. It will show you the error that this connection is wrong. These components can't be associated. Okay, for example, some wrong connections we have placed, some wrong voltage we have given. Okay, in that case it will give us the error. If there is no error, in that case we can move ahead. Now you can see that once it is done, after that, convert schematic to PCB. Either you can click on, you can use this option, design menu. In design menu, convert schematic to PCB. Okay, or what you can do, you can click on this option. Okay, its toolbar is option is also given. So this is the option, convert schematic to PCB. Okay, I will click here. So on click of this, now it is asking me to check this particular circuit or not. So it is verifying. It is asking to verify. Okay. So if I am confident that my circuit is fine, I don't need any warning. I don't need any particular message. So simply no, keep going. if I want to ensure whether this circuit is correct. For example, we are creating a circuit for a particular real world project for government agency. In that case, many times we have to make sure, if you are creating some circuit for defense, for military, for government sector, in that case many times we have to verify rather than rejection at later stage. Okay, no, keep going. Now simply clicked. Now it is asking me dimension of my PCB in this one. Okay, copper layer, how many layers I want to use, two layers or single layer. Okay, so two layer PCB, rectangular or circular. Circular PCB can also be created. You might have seen nowadays different designs, different types of orientations can you we can use, custom hexagonal, star shaped, so different, for example, just for designing. Okay, rectangular, so rectangular. Now apply. Now you can see this particular screen we will get. So what I have done, simply this is my circuit. I have clicked on convert schematic to PCB. After that we will get this, very simple. Okay, now, so I'm zooming it so that you will be able to see. So this one. Now, just now what we have done, just now we have selected rectangular, so it has given me a rectangular shape of same dimension, this much centimeter by this much, or this by this whatever dimension we have given. If we have used circular, then we might have opted for radius, that this one should be radius. Now this is my blank plate, this is my plate. Now I want to put my components. This is my DC. So simply drag. I want to put my DC here or here. So you can see that connections are not halting. Connections are not changing. Connections are, even if I place here, but here it is meaningless because my actual plate is here. Within this plate where I want to put my DC1. So this is DC1 here. For example, this one, my DC1 is ready. Now where I want to put LED1, LED1 I want to place here. LED2, simply drag and drop with your mouse or touchpad. Okay, I am using touchpad of laptop. These registers I am placing, this R1, R2 and this R3. Clear? Very simple. Now you can see with control S we can save it simply, as with any Windows application, control S. Now if I want to place here, for example, I want to make it in this format. Okay, now this is our circuit.
Is there any provision of auto placement?
Yes, yes, that is also available. Auto placement is also there. Okay, so in this you will get that particular option. Okay, so PCB information and this one. So I will show you that particular option. Auto placement is also there. Okay, so you can see that this one. Now this circuit, this PCB plate is ready with our components. Up to this point, any query? Is it clear? Very simple. Simply drag and drop, created our schematic, then to PCB and drag and drop. Now what I will do, so you can see that DRC checking. If I want to go for DRC checking, this is my bills of material, BOM. Now I want to view it in 2D format, in 2D view. So click on 2D. So this is my 2D circuit. Okay, so this is 2D. In 2D format it will be visible like this. Very simple. Now I want to view it in 3D. Click on 3D. This is my circuit, this is my PCB. So you can see that it will look, so bottom plate, its bottom second layer is complete, is only is currently empty. Okay, because there are some soldering. Okay, this one. Now after this I will show you how to optimize this PCB. Optimize means I don't want to use this much area. Okay, half area is sufficient, or one third area is also sufficient. How? By which way it is possible? Some components below on second layer. Okay, because one plate we have already occupied, so why not to optimize? Okay, so for example LEDs and registers, few LEDs and registers I want to place at bottom, and DC supply at top, that we can do. So this one first of all, so with my mouse or touchpad we can view by which way this particular PCB will be looking. Now if I am confident that it is fine, and we can change this dimension also, so you can see this width can also be changed. Okay, and this is also an area of research, that whether we can put some components on this width also. So it can be taken as an area of research, rather than taking two sides. We are taking left side or right side also. Okay, so that can also be done. So you can see that this one. Now if I want to change it, for example you can see at right hand side, board thickness 1.6 mm. Now I want to change it. Okay, 1 point, for example 1.2 mm. Now I want to take only 0 0.5 mm to reduce my cost, because it will ask how much copper I will use, how much copper material I will have to use. Okay, so if more width is there, in that case more copper will be used, more metal will be used. More metal means uh, one aspect is that it will occupy space, and along with occupying space it is of no use, because our purpose is not to throw it on floor just to check whether it is robust or not. Okay, we have to use it in our, for example in mobile phone this PCB to be used, or in some particular military application this very portable device, this PCB to be used. Then why to increase the width? So that can be reduced. Otherwise, if we want to put some components on this part, then we can increase. Now you can see I have placed it in 2.7 mm. In 2.7 mm, now you can see that this is having good width, but it is not required. Okay, 0.5 mm, this is sufficient. Okay, now board color, which board color I want to use? Red. In whatever board color I am giving, my PCB will be given in that color. Okay, it will be provided, because when we will order it they will send it by courier. Okay, so if we want to go for some designing or look and feel factor, that it should look impressive, it should look effective, that we can do. Okay, surface finishing, silver or gold. Okay, so for conductivity, for better results, many times we work with gold and silver also. Plating. Okay, because you are from electronics domain, you might be knowing better. If we will place silver plating or gold finishing, in that case, what will be the result? So silver or gold plating. This one. What is the background? So this one. This is our PCB. Okay, now once this PCB is ready in 2D format, in 3D format, now what we will do, this is the option bills of material, BOM. Okay, so different options available, so you can see that update PCB. Okay, and BOM, document recovery. Okay, now on click of BOM you can see that what about the price of each component we are taking. So 1K, 3 registers we are taking R1, R2, R3, manufacturer. Okay, so assign. So currently it is not mentioned in how much price it will come. So this DC is available in $0.1. This is in $0.03, but price of this is not given. So what will be price of my final product, my final PCB? So assign LCLC part. Now we will assign the cost. Okay, so it will give me so many options. Okay, I will select the optimal. I will select which is in my range, in our financial range. Okay, for example, this we are taking just for demonstration and assign. Now
सिमुलेशन सिमुलेशन कर सकते हैं हम लोग
हाँ जी,
सिमुलेशन वी नॉट डूइंग सिमुलेशन जैसे और सप्लाई देके लाइट ऑन लाइट ऑफ दैट इज
yes, 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 that
ऑप्शन इज
can,
देयर
yes, 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 that is also possible. Okay, so currently we are working about, we are covering about
how to make
how
it
to make it. Okay, so you can see that if that particular part we have taken and its cost is $0.002. In same way, if I want to take some other part, for example this part I want to take and assign, this is $0.02 dollars, $0.008. So you can see that, and its configuration can also be checked, 0.02. So any we can take. Now this is ready. Now one click order parts. Now my PCB is ready. Each and every component is associated with some price. Okay, now one click order parts. Okay, it will move to LCLC platform. Okay, so now in same way we will see. So for example, I'm logging in with my Google account. In same way, so what we have done, we have clicked on one click order parts. Now it is giving me quotation. Okay, create BOM or create price. So these components we have taken in our PCB. Okay, create BOM. So these we can verify to avoid any mismatch. So one quantity of DC, three quantity of LED, three LEDs we are using, three resistors we are using, one DC. Okay, now how many PCBs, quantity one or two? As simple as Amazon, as simple as any online platform. How to create, how to convert it in uh, multi-layered format. Okay, so this is one layered, so I'm closing it, this one. Now we will see how to convert it in multi-layered format. So you can see that this is the palette, this one. So this palette we will use top layer, bottom layer, top silk layer, bottom silk layer, top paste mask layer, different layers available. Okay, if we want to lay to address, if we want to use each and every layer, in that case we will use this palette. How much copper component we want to use? So you can see copper component, top layer, bottom layer, and multi layer. Non copper, where we want to take to use non copper, in between board. Okay, object. Now we will see very simple demonstration. So this is our PCB in two-dimensional mode. Okay, so click here. So I'm placing it in this way. Now we will see how to convert it in multi-layer PCB. Okay, this DC or this register I want to place somewhere else. Simply click, select layer, bottom layer or top layer. So you can see that at top right, this menu is available, bottom layer. So I want to place it in bottom. This LED 3 or this particular part, this also I want to place to bottom layer. This one also I want to place in bottom layer. Okay, now you can see that these are in light color. Now after creating this particular panel, we have to create connections also, because some components we have moved to another layer, so connection should be there. Okay, penetrating connections within copper layer, within copper plate. So you can see PCB tools, click. Now I want to connect this with DC. Okay, I want to place. So now I am coming to bottom layer. This is my bottom layer. Now in bottom layer, this connection, I want to connect this resistor with this LED. Okay, even if these are at bottom layer, still they will be connected. Okay, so this connection we have created. Now save. Now we will again see it in 3D mode. We will again check whether it is actually in top bottom format or not. 3D. Now you can see registers are disappeared from here. These registers are available here. So three registers at bottom, these LEDs at top. Now our size can be reduced.